thankful to Live Green Lexington for bringing you this exciting fun lesson that you're about to see. I hope you enjoy it. Today we are going to be learning about macroinvertebrates, and I have brought with me Mr. Blake Newton, who is an entomologist at UK. Thank you for joining us today, Blake.
Thanks, Danny, for inviting us.
Absolutely. Blake, what is a macroinvertebrate?
So a macroinvertebrate is the name for a kind of creature. Macro means it's big enough for you to see. Invertebrate means that it's an invertebrate creature, and invertebrates include things like worms and insects. And for our purposes today, we're focusing on macroinvertebrates that live in the water.
Well, today we actually brought some different samples that we have in our office. We can talk about how we figure out what they look like, right? Mm-hmm. So we have some different samples and they are labeled according to different colors. Blake, why do you think that we have these labeled in different color groups?
Yeah, so the way this activity works is you go down to your water body, your creek, and you start identifying the creatures in there. Based on which kinds you find, you can actually get a score that tells you how healthy your stream is. And so I imagine these are color-coded by how sensitive they are to impairments or pollution in the water.
Oh, that makes sense. That makes sense. Well, all right. Well, we've got about 24 different samples here today, but this set has been built and designed based on this guide, I guess. It was put together by a group called Save Our Streams. And we can't show them on the camera, so we got some blown up images. We have this creature right here. If I wanted to figure out what this is, what kind of tool would I use?
Well, there's lots of tools that you can use. You can just go on the internet, you can use books. But one of the things that we like to bring with us when we're doing this activity is a key, a dichotomous key.
Okay, so this is a dichotomous key. So this one says key to macroinvertebrate life in the river. So as Blake mentioned, we are looking for ones in water because macroinvertebrates can live on land as well, right?
Sure.
Okay. So a dichotomous key works. Di comes from, is that Greek or Latin?
I'm not sure.
It's one of those languages, but it means two. So it's a little misleading. Some of these are asking us multiple questions, but it looks like each time it's asking us one or two questions that we have to answer so we can identify what we're looking at.
One of the things that you will very commonly find is this thing, which I'm going to go ahead and call it a crayfish because a lot of us hopefully know what this creature is already. But to be sure that we know what it is, we want to take it through the key. So we start at the very top. And the very first question it asks is, does it have some kind of a shell that encloses its whole body, almost like an oyster or a clam or a snail? Or does it have no fully enclosed shell? And so this one does not. It still has what you might call an exoskeleton, but it's not a hard shell like a clam. So we say no shell. Then the second question it asks is, does it have legs or no legs? And pretty clearly we can see that it has legs here. So we go through onto the leg section. And then the next question, this is where Danny mentioned that sometimes we don't have two choices. Sometimes we have more than two. So this is not technically a dichotomous key, but it's still a key. So it's asking you three questions. Does it have 10 or more legs, 4 pairs of legs, or 3 pairs of legs? They have 1, 2, 3, 4, 5. The pinchers are one of the legs. And then 1, 2, 3, 4, 5 on the other side. And that adds up to 10 total legs. So you take the 10 legs answer, and now you have 3 things to choose from. So you've narrowed it down from a whole big mess of creatures that you might possibly find down to 3. That's why a dichotomous key is so powerful. And pretty clearly here you can see that the crayfish has a very distinct shape, and it's different from something like an amphipod, which you can also find in our streams, or an underwater isopod, which is also very common in the streams. So that's how the key works.
That's pretty cool. And it looks kind of like a lobster too, doesn't it?
Yeah. Crayfish and lobsters are very, very similar to one another. Crayfish live in fresh water, and then the lobsters are going to be a saltwater creature.
That's pretty cool. So we also have this one here, which you identified as a stonefly. Mm-hmm. But let's follow through the key. Can I try this time?
Yeah, definitely.
All right. So you said the first question we're asking is it shell or no shell? So I don't see anything on it like a clam or an oyster. So I'm going to guess that it has no shell. Is that accurate?
No shell.
All right. Then it asks if it has legs or no legs. Well, I can pretty clearly see some legs on this. So I'm going to go with legs. Now, 10 plus legs, 4 pair of legs, or 3 pair of legs. So I've got 1, 2, 3, and then is that a 4th leg?
Yeah, so these are antennas. Sometimes it's a little hard to tell the difference between an antenna and a leg. Just kind of use your common sense. These legs, if it has multiple pairs of legs, the legs are going to kind of look like each other, and they're going to have these very distinct elbow joints in them. And then the antenna are going to have tiny little joints, and they're going to look different than the legs. So this isn't a leg. This is called a cerci or an appendage, and these are antenna. So these are the legs, and there are indeed 3 pairs of them.
Excellent. So 3 pairs of legs. Now, wings or no wings? I don't see any wings on this, so I'm guessing no wings?
No wings.
No wings. Now, you said, what are these called again?
Well, okay, I probably used the word appendages or cerci,
Okay.
but on the key, it's actually using the word tails.
But it does put them in like quotation marks. So I guess that's why, because they're not technically tails like, say, a monkey or a dog would have. Okay. So no obvious tails. Well, I obviously see some tails.
Yeah, if this was one of the ones with no tails, and we do have ones that look very similar to a stonefly that don't have tails.
Okay.
But this one does have obvious tails, so we can eliminate those.
Excellent. So my next selections are 1 or 2 tails or 3. Well, I'm counting 1 and 2, so I'm coming down here. Now I have 6 options to look through. Now I'm thankful that Mr. Newton here told me what the answer is, but let's see what else I can use on this key to figure out what the answer might be. So a caddisfly larva tells me it has a dark head. I can't really tell from this image. Green or tan body. Again, you can see something different when you actually capture them in the stream. And then brush-like tails. Now that's pretty handy because these don't look like brushes, do they?
No, if this was a caddisfly, it would have lots of little hairs coming off of here, and the tails would also be a lot shorter.
Okay, that's really handy. The alderfly, it looks like small and spines on the side, and it looks like it's little things here along the, is this the abdomen, or what is this portion?
Yeah, this would be the abdomen, and it would have some little spines or spikes coming off of here, and they tend to have 1 long tail instead of 2.
Okay, so it's definitely not that. We have a dobsonfly, and that looks like it's got hundreds of legs, but it looks like those are also little spines, so we know it's not that. We get to the stonefly, it has tails that are long and stiff, and it has long antenna. So we know that this is the stonefly, right?
Right.
But we'll go through the other 2 just to make sure. So the mayfly has flat gills on the abdomen, so I can't really tell what a gill looks like from this image, or if we're not caught one in the stream, what other suggestion can you give to us?
Yeah, so as you learn more about the aquatic macroinvertebrates, you'll learn that it's the 2 groups that are kind of difficult to tell the difference between that you'll find often are stoneflies and mayflies. Most of the mayflies have 3 tails, so there'd be a 3rd one down here. Makes them pretty easy to separate from the stoneflies. But there are a handful of mayfly species that have 2 tails. So initially they will look to you like a stonefly. But the way that we tell the difference is that the mayfly will have gills on their abdomen, and the stonefly will have gills up here near the legs. It's kind of hard to tell that on a picture, but when you see one in real life, it's a little easier to see. In fact, the mayflies, the gills on their abdomen will actually be moving around in the water.
Oh, that's really cool.
So you can see them pretty clearly, whereas the stonefly abdomen is going to be bare.
Okay.
No gills on there. So that's how we know that this one is a stonefly instead of a mayfly. By the way, the real size of this creature, and this is why mayflies and stoneflies are sometimes hard to tell the difference between, they're about this big. So they're about an inch or a little less than an inch. So, and you'll tend to find mayflies and stoneflies in the same water, and it's good to be able to tell the difference between them.
Yeah, those are definitely pretty tiny. And then a predaceous diving beetle, it looks like it also has some brushy-like tails. So, and it looks like it hangs from the surface.
Yeah, if you and I rarely find predaceous beetle larvae anyway, but when I do, they tend to be close to the surface instead of under rocks, and they have big heads with like sickle-shaped mandibles that cross over each other. So they have this very formidable looking head that looks very different from these guys.
Well, that's pretty cool. So this is definitely a stonefly larva.
Stonefly, yeah.
Pretty cool. Well, thank you for walking me through that. So let's talk a little bit about how these guys, we use them to talk about water quality, right? So you mentioned that we have them based on, kind of organized based on how sensitive they are to water. What does that mean?
Yeah, so in a water body in Kentucky, we're supposed to have hundreds of different kinds of creatures that live in that water. If you were in a pristine mountain stream, there would be hundreds of different species that live there. But as you get closer to urban areas, you get impairments and pollution. You get things like too much sunlight because the trees are removed, or pollution coming in from streets, not enough rocks for the creatures to live under. And as those kinds of impairments build up, fewer of these creatures are able to live there. And we know this from examining the streams, that there are certain creatures that you will find in very healthy streams, and there are some creatures that you will not find when you go to less healthy streams.
Okay.
And so you guys have this organized by, it looks like the blue ones are the ones that are, looks like the blue ones are your middle ones, and the green ones are your, no, it looks like you have the blue ones as the most sensitive, and so that makes sense. So the way these are labeled, if you find, and these are actually some more stoneflies, for instance. If I find a stonefly in a stream, because I know that it's very sensitive to impairments, I know that my stream is less impaired than maybe some other streams. And there are a handful of these creatures that we consider more sensitive. The mayflies, the stoneflies, some of our mussels, some of the fly larvae. And when you find those, it's a clue that your stream is a healthier stream than some of the other ones. But there are some other creatures that can live in almost any kind of water quality. And these are labeled with red stickers on here. What do you have there?
This looks like
that is a leech. Yeah, so leeches can live in all kinds of water. They can live in the healthy water too, but when water becomes pretty unhealthy, a lot of these ones that are labeled blue, a lot of those start to die off, and that leaves room for the leeches for their populations to increase. So when you get into a stream, an urban stream that has lots of impairments, lots of pollution, you'll tend to find a lot of leeches and maybe a handful of certain kinds of snails that really proliferate and get large populations in that kind of environment, but very few mayflies and stoneflies.
So if I find this is a leech, the water could be healthy.
Yes.
But I want to see what else is there.
Right, you want to see what else is there.
Okay. Now, you and I were discussing this really handy app called Water Quality, and it was designed by Northern Kentucky University. So if I open it up, it's going to ask me a little information about, okay, here's the date. It's telling me the latitude and longitude, so it looks like it's got some GPS already in it,
yep.
So it knows where I am. And it's asking about air temperature, water level, weather, and a few other things like DO, which stands for dissolved oxygen, fecal chloroforms, which are things we see whenever we have lots of livestock nearby. Is that fair?
From livestock,
the water temperature, pH, how acidic or basic the water is. But here we get into this benthic macroinvertebrate. So how would I use that?
Yeah, so if you're a group that has been trained to test dissolved oxygen or some of those other parameters, you can do those, but you don't have to do those to do this app. You can just go straight down to the section about macroinvertebrates. And what it shows here is it shows outlines of these creatures that we just talked about. The stonefly nymph, the mayfly nymph, the caddisfly, and some of these other creatures. And it's basically asking you if they're there or not. And you start looking at these creatures and you're saying, did we find any stonefly nymphs? And so you start looking through here and you say, yes, we did find one. So you click the little plus button. That means you found one. And then there's also, when you click the silhouette itself, it brings up a better picture of the creature and talks about it. Tells a little bit more about how to identify that and what kind of streams it's going to live in. So it'll sort of explain why you might find it in healthy streams versus unhealthy streams. And you go through all the creatures, and there's really only about 20 or 30 creatures there. It's not a huge list, so it's a doable list, and you can learn them pretty quickly. And the way that the app divides it up is that the creatures that are the most sensitive to pollution are up at the top, the mayfly nymph, the stonefly nymph, riffle beetles, and a few other creatures. Those are going to be worth, I believe, are they worth 4 points here? Are they worth, what happens when I do one here? They're worth, I believe, 4 points each. And then when you go down to the next section, which are creatures that can handle a little bit more impaired water, but still can't live in the very most impaired water. Things like dragonfly nymphs, aquatic salvos, which are very common around here. They look like underwater roly-polies. Those are worth fewer points. And then when you get down to the bottom, you have things like midges, leeches, rat-tailed maggots, and a few other creatures that can live in highly impaired water. And those are worth the least amount of points. And at the end, you get a score. Your score will probably be somewhere between the 20s and the 30s or more, depending on how healthy your water is. So the idea is you use this app, you add up, here it goes. It actually gives you a nice little scale. If you get a score of 23 or more, you have excellent water quality. And if you have less than 10, you have poor water quality. It adds this up for you as you go.
Well, thank you so much, Blake. It was a pleasure having you here today.
Yeah, thanks, Danny.
See you all later.